Hi, this is Dr. Lashik, and this lecture we're going to talk about external validity and generalizability as it relates to populations and sampling techniques. When we talk about generalizability, what we're doing is we're questioning external validity. In other words, what we're asking is, do the people that are studied in a research project actually represent the population of interest? And this is an especially important question when considering frequency claims. For example, let's say we are interested in getting information from the website ratemyprofessor.com, and we are reading about a potential future professor we plan on taking. And while we're doing this, we should probably be asking ourselves, do all of the students who actually went and used that website, who actually rated their professor, adequately represent the students who took that professor's course? If they don't, then that information that we are getting from that website is probably less valuable. Think about it. What if only the students who failed that professor's course decided to go on ratemyprofessor.com and rate that professor? If that were true, would we take the information that we gain from that website as more valuable or less valuable? Probably less valuable, because those students don't adequately represent the students who took his course. And so that's exactly the type of question we're going to be asking when considering populations and samples in research studies. We want to know if the people studied in a research study adequately represent the people they are attempting to describe. So when we hear the term external validity, it involves both sampling techniques and also settings. This chapter and this lecture is only going to consider external validity as it relates to sampling techniques. However, it can also be used as a word in the context of experiments. And in that case, what we are doing is we are thinking about, okay, after the researcher has done an experiment, we might be reading that experimental conclusions, and we would ask ourselves, do these conclusions adequately, could they be transferred, or would they be found in other settings as well as the laboratory settings that they were performed? And so in that way, we are considering the generalizability of the conclusions. In this chapter, again, we're only going to be considering generalizability as it relates to sampling techniques. And we will talk about generalizability with experimental conclusions and settings in a future chapter. All right, so let's start off by talking about the difference between populations and samples. A population is the whole group of people or animals or subjects that we are interested in describing, while a sample is the smaller subset of that group that we are actually studying, because it is very difficult to study all of the population of interest. We then take that information that we've gathered, and we then attempt to generalize that information collected from the sample to the population. If we do manage to study every member of the population that we are trying to describe, what we are doing is we are conducting a census. Let's use the example of eating potato chips. Let's say we are curious about a particular brand of potato chip, and we want to know if we're going to like that brand of potato chip. And what we do is we try a sample chip out of the bag. We can assume after we've eaten that one sample chip that all of the other potato chips in that bag taste the same. And then we can come to the conclusion, based off of that one sample chip, that we like or dislike that brand of potato chips by that one chip. We don't have to eat every potato chip in the bag, or we don't have to eat the population of potato chips to come to the conclusion that we like those potato chips. We can base our conclusion off on the sample. Similarly, researchers do not need to study every member of the population typically. What they can do is they can assume that the sample that they studied behaves the same way that the population behaves. But the only way they can do that is if their sample that they studied adequately represented the population of interest. In other words, it had an adequate amount of external validity. So before we can assess whether or not our external validity was adequate, we have to ask ourselves what our population of interest is. Let's use the example that we are interested in studying teenagers in the United States and their desire to have kids when they grow up. In this case, our population is not everyone on the planet. Usually researchers don't have any interest in study or generalizing their information to everyone on the planet. Usually they say something like women or teenagers in the United States or college students. These were all populations of interest. But even then, they can't study every member of those populations. So in our case, for our example here, our population of interest is teenagers in the United States. And then we sample from that population those who we will study. And we hope that those that we have sampled adequately represent the population of interest. For instance, we might measure teenagers who attend the local high school and hope that that sample is representative of the population of interest. We hope that our local high school's teenagers are similar enough to the rest of the United States teenagers. So there are a few rules about selecting an adequate sample that's truly representative of the population. One rule is that our sample needs to come from the population of interest. So we must actually select our sample members from that population. A great example of this is if we are interested in studying teenagers from the United States, we should probably not sample people from the American elderly. That's not going to give us a representative sample. However, that rule is necessary but not sufficient to give us a representative sample. Just because we've selected people from our population of interest does not mean they adequately represent that population. So the samples that we do choose from that population of interest can either be biased or representative, and we're striving for a representative sample. It's biased if certain members of the population have a higher probability of being selected to participate in our study, while it's representative if all members of the population have an equal chance at being included in our study. For example, if again we're interested in describing United States teenagers, so that's our population, but we go to our local high school and only select students from that local high school as our sample, it's not representative, it's biased because our local high school students had a much higher probability, a higher probability being compared to 0% chance that other students would have of being allowed in our study. There are a couple of rules of when our sample is biased. If we only select one person, it will always be biased. It's very highly likely that that one person has several idiosyncrasies about them and that they do not represent most other people in the population. Again, we're interested in studying American teenagers. We go to our local high school and just by random chance, we only select one person. We happen to accidentally select the one straight A student in the high school who plans to be an astronaut when they grow up. And when we ask them about their preferences for having kids when they grow up, they say that they are probably not very interested in doing so because they plan on going into outer space soon after they turn 25. Okay? So this one person does not represent the typical American teenager in the United States. Again, most people have a lot of idiosyncrasies, but if we chose a lot more students, their idiosyncrasies cancel each other out, and we don't have to worry about accidentally selecting one person who's so far off base the representative sample. So again, having more bodies in our sample is necessary but not sufficient at acquiring a representative sample. Let's say we are aware that there's a problem with selecting only one person, and we are aware that that person's idiosyncrasies could ruin our results. So we decide we're going to select a lot more people. So we go to our local high school and we select more people, but to make it easy on ourselves, we only select them from the NASA club at that school. And we find that the results are just the same as if we had only talked to one person. And that's again because we didn't do an adequate job. Again, the population of interest is American teenagers, and only this small group of students in a NASA club at our local high school actually had the opportunity to be a part of our study. Therefore, the probability was much higher for them to be a part of it, and we have a biased sample. There are two main ways to get a biased sample. One is through convenience sampling, and the second is through self-selected sampling. Convenience sampling is studying only people who are easy to contact, and self-selected sampling is studying only people who are eager to participate. People who are easy to contact and people who are eager to participate might be very different from people who are hard to contact and less willing to participate. So let's start by talking about convenience sampling. Convenience sampling, again, is studying only those people who are easy to contact. Unfortunately, many psychology studies use a convenience sample by studying the students of the university that the researchers happen to teach at. Most of the time, researchers have to get their income through teaching at a university. Oftentimes, professors have their work obligations split up in half. Half of their work obligations is to teach courses, and the other half is to do research. What better way to find participants for their study than use the people who are readily available to them? Unfortunately, this does create a convenient sample because it's only studying those people who are easy to contact. It's easy to see how university students are probably very different than the rest of the population or populations that we are trying to describe. For instance, college students, just by being college students, typically have more education than other people and therefore have different opinions in other areas as well and different psychology. Another problem is that there's usually a select age range in college student populations, and that does not necessarily represent the population as a whole. This is why a lot of psychology studies say, here's some psychological phenomenon that we've discovered as it relates specifically to college students. So what they do is they make it so that their population of interest is college students, so that when they sample from the readily available college students they have at hand, they don't get in trouble for convenience sampling. Another great example of convenience sampling is that of exit polling. And exit polling is when people ask others, they sit outside of a polling station and they ask people who they voted for as they exit that polling station. And this could be easily biased. There's two main ways that this is typically biased. Number one, if the exit pollers only poll at specific polling stations, this could be a convenience sample, because we know that certain counties and towns and certain areas of a town are typically more liberal or conservative than other areas of that same town. And only polling at one particular polling station may not represent the city as a whole. The second way, we have to remember that the people who are doing the polls are they're human, and so they might have a bad day that day and not feel like approaching every single person that comes out of the polling station. Maybe to make it easy on themselves, they approach only likable and friendly people to ask who they voted for. This is a convenient sample because they're only contacting the people that they feel are easiest to contact. Who they feel they would have the best experience contacting. But again, as you could probably imagine, People who are easy to approach may not represent everybody in the city. So this is considered a convenience sample because only assessing the closest polling station and only assessing those easy to approach is not necessarily representative of an entire population. The problem with convenience sampling is that sometimes, despite our best efforts at avoiding it, we can accidentally create a convenient sample. Sometimes convenient samples are created because researchers can only contact certain people. For instance, sometimes it's close to impossible to contact people who refuse to answer their phone. Or sometimes it's close to impossible to contact people who don't have internet access because they just simply can't afford a computer with internet access. Inadvertently, researchers are then creating convenience samples because of this. You could imagine that people who refuse to answer their phone and people who can't afford a computer may not represent, or leaving them out of the sample might make it so that our sample does not represent the population as a whole. The second main way to create a biased sample is through the self-selection process, and that again is surveying only people who are eager to participate. This is when people seek out research participation opportunities and then choose to participate. All online surveys are considered self-selected samples. A good example of this is when in a poll that was conducted online, asked people about raising children, and it determined after the poll was completed that 32% of respondents had children who learned to read by the age of 3. This is a very biased sample and biased results because of that. Because people who self-select to participate in a raising children survey are the type of people who like to brag about their kids. Also, this survey was posted on a website for gifted children, so already people visiting these websites are already more likely to have gifted kids and therefore have a child who reads at an earlier age than most people. So that 32% is highly inflated, and it all has to do with the fact that it was a self-selected sample. Again, I have to repeat this. All internet surveys are self-selected. People who care enough to go online and seek out a survey and participate are likely very different than most other people. So we'll continue talking about what creates a biased sample in the next slide, but let's move over and talk about what creates a representative sample, and then we'll finish talking about the different bias techniques. So we just discussed how convenient sampling and self-selected samplings can produce biased samples. They have a high probability of producing biased samples. To get away from that, what we can do is use different probability sampling or random sampling techniques to help correct for this. Probability sampling and random sampling are techniques where everyone in the population has an equal chance of being selected to participate, regardless of how easy they are to contact or their willingness to participate. If these are used correctly, we would have great external validity. Let's start with the very first one on the list, simple random sampling. Simple random sampling is where everyone in the population has an equal chance to participate. Each person is randomly selected by the researchers, and then those who are selected make up our sample. Pretty easy. For example, everyone in the population of interest writes their name on a piece of paper and puts it in a hat, and then the number of pieces of paper that are pulled out equal the number of people you desire in your sample. And then those are the people who are used. This is usually done by assigning numbers to everyone's name in the population of interest, and then generating a random number list using a computer. For example, previously, exit pollers did this, by randomly selecting a list of phone numbers and then calling those people. But that worked back when everybody had landlines and no caller ID, where it was pretty much expected that if your phone rang, you answered it. And nowadays that's no longer the case, so it's no longer effective. As you can imagine, simple random sampling is very difficult. It requires us knowing every single person in the population of interest, which is usually almost impossible, especially when the population of interest is something like all women or American teenagers. It is very difficult to get a complete list of everybody in that category. This is why psychologists typically use another less strenuous method of random sampling. So let's move on to cluster sampling and multi-stage sampling. Cluster sampling is when clusters of participants are identified, and then researchers randomly select certain clusters of participants, study those people in that cluster, and then that's who makes up their sample. For example, let's say we are interested in studying U.S. college students, so that's our population of interest. We would then get a list of every college in the United States, which is a clusters, that's our clusters of people. And then we randomly select some of those colleges and then study all of the students from those colleges selected. Okay. Multi-stage sampling is very similar to cluster. It combines cluster sampling with simple random sampling. So you do exactly what you did for the cluster sampling, where you cluster sample, and then instead of studying every single person in those clusters, you then randomly select participants within those clusters to study. For example, let's say our population of interest is Indiana college students. So we would start by cluster sampling, randomly selecting maybe 3 Indiana universities. And then we would randomly select students from within those universities to study, maybe 50 students within those universities. Let's move on to stratified random sampling. Stratified random sampling is where you have a preconceived notion about what you want to do with your data when you're done. So let's say you're particularly interested in comparing certain personality characteristics between one group of people and another group of people. But you're also aware of the fact that maybe the groups aren't equally distributed amongst your population of interest. And so you have to get a little creative in how you deal with that problem. Stratified random sampling is where you know that your demographics of interest are not evenly proportioned. And so you pick your specific demographic categories, and then you make sure that you have a specific number of participants in each of those demographic categories, even if it does not represent the proportion in the typical population. A good example of this was with my dissertation research. I was interested in comparing sexual assertiveness between women of all ages. If I just simply used simple random sampling and left it up to random chance what age groups I would get, I would have received probably 60 to 70% of my participants would have been women between the ages of 20 and 30. But I really needed women between the ages of 50 and 60, and many between the ages of 40 and 50, etc., etc. And I knew if I just left it up to chance, I wouldn't get enough people to be able to make adequate comparisons between one group and the next. So what I did is I set parameters, and I said that I needed 50 women that were between the ages of 20 and 30, which were really easy to obtain, but then I also set parameters for the other groups as well. And if a woman approached who was between the ages of 20 and 30, but I had already fulfilled that bracket of ages, she did not participate. This is still considered random sampling because all of the women within each age range was selected randomly. The next one is oversampling. And this deals with that same problem of having specific demographic categories you wish to compare, but recognizing that um, those demographic categories don't necessarily represent an equal proportion of the population. So again, oversampling is needing a specific number of people in a specific demographic group, but knowing that they represent a smaller proportion of the population. If we just left it up to random chance, that proportion will not yield enough people of that demographic to draw conclusions from. So we randomly sample normally, and then when we're finished, we go to the specific demographic of interest and then continue sampling until we have enough data to work with. Then, to correct for this difference, the data is weighted to correct for the fact that they truly do not represent that much of the population. Let's give an example of this. Let's say we're interested in studying people who ride horses. That is our population of interest. We know that most horse riders live out in the country, but we also are aware that there are a few horse riders who live in the city and decide to commute to a horse ranch on the weekends. For whatever reason, through our theory and hypotheses and whatever it is, all of our previous research, it is very important to us to study the difference between these city dwellers and these country dwellers. And in order to do so, we need an equal number in both categories. So again, if we left it up to random chance, we know that they only represent about 3% of the horse riding population. So if we sampled 100 people, we would likely only get about 3 people who live in the city. This is not enough to draw conclusions from. So what we might do is do simple random sampling techniques, get our 100 people, expect that we would only get about 3 city dwellers. Then once we're done with that, we would oversample by visiting maybe the city equestrian club and then get data from them until we have enough data to work with from city dwellers specifically. And then when we go to analyze our data, we would weigh the responses of the city dwellers to correspond to their actual proportion in the population, which is 3%. The next technique is systematic sampling. This is where we would randomly choose a couple of numbers and then select people who correspond to those values. For example, we might select the number 4 and 7 and then pick every 4th and 7th name on a list of people that would represent our sample, or the 4th and 7th person in the room. In other words, we're taking a number and we're just randomly applying, we're applying it to some order or some list or some ranking. So combining techniques. You might notice as you're doing research that many researchers combine a lot of these random sampling techniques. And this is a fine idea. As long as people are selected in some sort of random way, we will still have very good external validity. And again, this means that no one from the population is excluded from the sample for any reason that might lead to bias. Just as a reminder, make sure you understand the difference between random sampling and random assignment. Don't confuse the two terms. Random sampling concerns with what we were just discussing, so selecting people randomly to make our sample representative of the population of interest. This deals with external validity. Random assignment, however, is only applicable in experimental designs. And experimental designs contain multiple conditions in an experiment, right? So like a treatment group versus a placebo group. The random part of that is when we randomly assign people from our sample into either the treatment group or the placebo group. This ensures internal validity, or makes sure that the results weren't affected by the group each person was a part of. And we'll talk about this in a lot of detail in a future lecture and chapter. So we discussed already the difference between convenience sampling and self-selected sampling, and those are the two types of biased sampling techniques that happen to occur most often and are most easily accidentally generated. But sometimes we can actually settle for an unrepresentative sample. We can actually settle for one of these biased sampling techniques. And the picture here to the right only shows 4 different biased sampling techniques, but we're actually going to talk about 5. And the 5th one is called quota sampling. All right, we can settle for an unrepresentative sample when our study is not intended to be generalized. Then we can take the easy route and use one of these 5 different bias sampling techniques. We already talked about convenience sampling. Again, that is studying those who are easiest to contact. A good example of this is our psychology students in your university. Purposive sampling is selecting only people of a particular demographic that fit your population of interest in a non-random way. For example, let's say you want to study smokers. So what you do is you take a flyer and you hang it up in a tobacco store as an advertisement for your research. This is considered a non-random method of recruitment because only smokers who happen to visit that store have a chance. Plus, it's self-selected because they have to see that flyer and then decide that they would like to participate. Snowball sampling is where we would have, let's say our population of interest is very rare. We might ask the few participants that we know of to help us find more people that fit those characteristics. For example, let's say we're interested in studying parents who are raising children with autism, but we might know only 2 sets of parents who fit these qualities. We would then, after we're done studying them, ask them to recruit more parents who they might know who also are in the same boat as them. Perhaps those 2 parents that you know attend a support group for parents with autistic children. Then those people would then be asked to find maybe 2 more sets of parents, etc., etc. So if every set of parents that you study finds 2 more for you, you're exponentially increasing your sample size. The problem, though, is that this is, of course, non-random. So only those who know of the previous participants would have any chance in getting selected for your research. So again, self-selected sampling is only studying those who are eager to participate. We've already discussed that. Remember, all internet surveys are considered self-selected. And then finally, quota sampling. This is very similar to the stratified sampling technique we discussed in the representative techniques, except the difference being that the people who are recruited are done so in a non-random way. So again, just like with stratified sampling, we develop categories that we need certain numbers of participants in to make valid comparisons when it's time to interpret our research data. So we select participants to fill those categories, but in quota sampling, we are doing so in a non-random way. Whereas with the stratified sampling, we attempt to do so in a random method.